Hello, this is Jack Jackson back with just a little bit more work on the angle side condition. We have the angle side triangle congruence theorem, and that is if we're given two triangles with the angle side conditions there, they have to be congruent. So the angle side condition said we have two sides, in this case it's the two red sides here and here that are congruent. So triangle ABC and DEF, they're corresponding, A corresponds to D, B to E, and C to F. And so AC, the distance from A to C, which we might call distance B, is the same as the distance from D to F here, which is also going to be B. And then the angles C and F are congruent. So that is the angle here. Let's make that a little bit thicker. So those green angles are congruent. And then the angle opposite the side. So this, these angles we've got marked in blue. Those are also congruent. Okay, so it's angle side. Okay, now I'm going to show you a proof that doesn't depend on the Triangle Angle Sum Theorem. We'll do that first. So the first part is we know that there's a point G somewhere on ray FE, and we want to make it in such a way that this angle here, this orange angle here, is the same as the orange angle here. Now what we're going to end up seeing is that G has to be at point E. That's what we're going to prove. But at this point we don't know what the angle is at D, so it might be a little less or might be a little bit more. Turns out that's not possible. Turns out the only thing that is possible is for G to be E, but we've got to prove that. But we do know that there is a unique angle there, and that angle, when we make it, that ray will intersect this point at exactly one place up here, and so there is a point there. So the next thing we're going to do is we prove, what do we prove? Well, we know that this angle is congruent to that angle. Okay? We know that the red side is congruent to the red side, and the green angle is congruent to the green angle. So we know that triangle GFD is congruent to triangle BCA by the angle side angle theorem that we proved in an earlier part. And so because of that, that means those two triangles must be congruent. And among other things, that means that the distance from F to G is the same as the distance from C to B. It also means that this angle angle at D is the same as the measure of angle at A. Okay, and it means that these angles up here at the top are the same. Okay, now in particular it means that this angle here, FGD, is the same as this angle here. But one of the things that means is, suppose G is not the same thing as E. What if it's out here? Then it actually makes a triangle here, and in the angle inside here, the interior angle is the same size as the exterior angle. That's not possible, because one of the theorems that we have from Euclidean geometry and hyperbolic geometry for that matter also is that this exterior angle must be greater than the angle, each of these remote interior angles. It must be bigger than this angle here. So they can't be the same. And so because of that, it won't work out that way. Or if you put it this way, this angle over here, if it's on this side, this one's the exterior angle to this triangle. And so it's got to be bigger than this one. Well, they're not. They're the same size. So the only way that can happen is if you don't really get a triangle from G to E to D. It's actually just a line segment. And so G and E must be exactly the same. One of the reasons why we do this proof is this proof doesn't depend on the angle sum theorem, so it doesn't depend on the parallel postulate. And this same proof works in something called hyperbolic geometry. That's not really important for an elementary geometry course or a trigonometry course, but it is for a college geometry course, and my students in that course may be watching this video as well. as the ones watching it in the trig class. Now there's an actually easier proof with the triangle angle sum theorem, and that just goes like this. If we get these two angles are congruent and these two angles are congruent, then the third angle has to be congruent, and so the two triangles are congruent by angle side angle theorem. And we get the third angle congruent by the triangle angle sum theorem. So that's the proof. The last proof that I just went over is the proof that's usually given in a high school book. Okay, so there's a proof of the angle, actually two different proofs of the angle side congruence theorem.